Now for example 5, we're going to go a little bit further into the algebra of plugging stuff into functions. Here we're going to plug in some numbers, and we're also going to plug in some expressions into the functions and then run through simplifying them and working through the algebra and so forth. So the first function we're going to look at is f of x equals x squared plus 2x plus 3. We're going to do f of 4. To do f of 4, wherever x is inside the function, I'm going to replace that with a 4. So we have at the front, we have an x squared. That's going to turn into 4 squared. And then the second term is 2x, so that's now going to be 2 times 4. The last number is plus 3. So I'm plugging the numbers in here for x. And now I can actually calculate the output from the function by doing all the math here. So 4 squared would be 16. 2 times 4 is 8. So 16 plus 8 plus 3. That would equal to 27. So f of 4 is equal to 27. The next thing we'll check is what happens if we do f of negative x. To do f of negative x, wherever x is located, I'm going to substitute in a negative x there instead. So it's going to turn into negative x squared plus 2 times negative x plus 3. Negative x raised to the second power is going to the second power is going to turn it back into positive again, because when we square negative, it turns into positive. So it's just going to go back to positive x squared. Then the next term would be negative 2x, and then finally the plus 3. That would be f of negative x. And then next part says f of x plus 3. Now this is a little more complicated because we're plugging in a full x plus 3 into the function. So again, imagine the locations where x is located in the original function. In the place of where x was, I'm putting x plus 3. So it'll be x plus 3 to the second power plus 2 times x plus 3 plus 3. Now to do the algebra here, we have to expand the x plus 3 raised to the second power. X plus 3 raised to the second power would be the same thing as x plus 3 times itself. So that would be x plus 3 times x plus 3. So let's go ahead and write it like that. Okay. Now to multiply x plus 3 times x plus 3, we're going to have to FOIL. So we got to take the first x times x, so that'd be x squared. The outer, so that'd give us a 3x. The inner, so that'd be another 3x. And then the last, 3 and 3 multiplied together. So at the end we'll have a plus 9. Now in addition to this, we'll go ahead and keep working our way through the rest of the terms. Notice how the 2 in front of the parentheses, I can distribute that 2 to make this into 2x plus 6. And then at the very end, it's still the plus 3. Now we're going to combine like terms together. We'll still have x squared in the front. We'll count up the number of x terms we have here of 3x, 3x, and 2x. Those add all together to give us 8x. 9, 6, and 3 would add together to get 18. So x squared plus 8x plus 18. Now let's do another function. This one is f of x equals x squared minus 3 all over x. And if you'd like to give this a shot on your own, this is a good point. You may want to pause the video and try this on your own. So the first thing I'm going to do is calculate f of 3. We'll do that again by wherever x is in the original function, that's where we're going to substitute our number. So up on top, we're going to substitute in a 3 for x, and then a 3 for x underneath as well. So it's going to look like 3 squared minus 3 all over 3. So that'll turn into 9 minus 3 divided by 3. which would be 6 divided by 3, and that would be equal to 2. Let's also try doing f of negative 2. And this is a good one if you'd like to pause the video and try this on your own. And see what you get for calculating f of negative 2. Like the last one, we're going to substitute in negative 2 for x. And so it looks something like this. Now negative 2 squared is positive 4, so 4 minus 3 divided by negative 2 would be 1 divided by negative 2, or that could also be negative 1 over 2. Either one of these are the same. So that's what f of negative 2 is equal to. Let's also try f of negative x. So to plug that in, again, where x was located, we're going to substitute in negative x. So I have negative x squared minus 3 all over negative x. So negative x squared will just turn into positive x squared minus 3 over negative x. And really, that's all we have to do here. For the next example, we're going to construct a function from this description. It says that a company that manufactures TVs has a fixed costs of $300,000. It costs $180 to produce each TV. The total cost for the company is the sum of the fixed costs and the variable costs of $180 per TV. Write the total cost function, capital C, as a function of the number of TVs produced, x. And then we can calculate and find numbers like C of 100. So we're coming up here again with a function for total costs, which we're calling capital C. And as a function, we'll call that capital C of x. X is the input for the number of TVs. So the total costs is equal to the fixed costs plus $180 per TV. So we multiply that times the number of TVs. So our total cost function could be written as the fixed costs, which it says it's $300,000 plus $180 multiplied times the number of TVs, which again is represented by the letter x. So 300,000 plus 180x would represent the total costs as a function called C of x. If we wanted to calculate C of 100, we plug in the number 100 for x, so that'd be 300,000 plus 180 times 100. That comes out to be 318,000 for $318,000. So that's the cost to produce that many TVs. So that 100 TVs. Now our next thing we're going to talk more about are some of the graphs of functions and how to read the information from the graphs. So from this picture, we're going to find the value for g of negative 4, g of 0, and where g of x is equal to negative 1. Okay, when we try to find g of negative 4, keep in mind that the negative 4 is representing the number for x. So we're going to look along the x-axis at the number negative 4 and locate what is the value of the function for that value of x. In this case, the value is 2. So g of negative 4 is equal to 2. For g of 0, we'll look at the number for x where it's located at 0. And we see that over here, and we notice that the y value is also 0. So g of 0 is also equal to 0. Now the last part says where g of x is equal to negative 1. So we want to know, what is the x value? So we look at the graph and we see where negative 1 occurs right down here on the y-axis, and we want to locate what is the value of x to make that happen, and that's going to be at positive 1. So the connection here is at x equals positive 1, g of x is equal to negative 1. So that's the answer for this one. We're trying to locate that x value to see where the function is equal to negative 1. Now in this next example, we're going to determine the domain, the range, and any x or y intercepts from the graph. One thing we're going to do is write the domain and range in interval notation. So to start off, when we look at the graph, for the domain, we'll be looking at the x-axis, and for the range, we're going to be looking at the y-axis. Since x's are the inputs where we start, that's what we call the domain. The range is what we get out of the function, and that goes on the y-axis. So looking at the domain along the x-axis, notice how this function continues to go both to the left and to the right, and just continues to do that off of our graph. That means it continues forever in both directions. That means our domain is all real numbers, which we usually write in interval notation as parentheses negative infinity, comma positive infinity, close parenthesis. Notice for the range how the graph goes all the way down to negative 4 on the y-axis and then turns around and goes up from there. It never goes down below negative 4 on the y-axis. So when we read the range, we say it goes from negative 4 all the way up and off toward positive infinity. Now when we write that in interval notation, we write it as bracket negative 4 comma infinity. Notice I'm using the bracket here. That's specifically because it goes all the way down and touches negative 4. So in bracket and interval notation means it actually touches and goes through the number. Now for the x and y intercepts, we locate where does it cross the x-axis and where does it cross the y-axis. It crosses the x-axis at negative 3 and positive 1. So the x-intercepts are negative 3, 0 and 1, 0. For the y-intercept, notice it crosses the y-axis down at negative 3. So the y-intercept is 0, negative 3. Now on this graph, when we take a look at the domain, we're looking along the x-axis, and we notice how the graph goes from 0 to 5 along the x-axis. So that's going to tell us about the domain, but we'll pay close attention to the fact that there's a filled-in circle on one end and an open circle on the other end. In interval notation, how we're going to deal with that is, for the filled-in circle, we're going to put a bracket for that number, and at the very end at number 5, where the graph stops, we're going to be using a parentheses for the open circle. So our domain is going to be written in interval notation as bracket 0, 5, close parenthesis. For the range, we're going to look at the y-axis numbers. So look at the y-axis and how it goes between negative 1 at the low end and positive 5 up at the top. For the filled-in circle, again, we're going to use a bracket, and up at the top for the open circle, we're going to use a parenthesis. So the range is negative 1 with a bracket, 5 with a parenthesis. The x and y intercepts, we notice that it crosses the x-axis at 2, so 2, 0 is the x-intercept. It crosses the y-axis at negative 1, so 0, negative 1 is the y-intercept. Now for this graph, the domain, we look along the x-axis, notice how it starts at 0, but the graph points off toward the right, so it continues off in that direction. The domain would be bracket 0, comma, infinity, close parenthesis. For the range, the lowest number on the y-axis is 1, and it starts from there and continues to go up and off the graph continuously, so it never stops. The range would be bracket 1, comma, infinity. For the x and y intercepts, in this case, it never touches the x-axis, never crosses it, so there's no x-intercepts. For the y-intercept, it does touch and cross the y-axis at 0, comma, 1.